Okay, so this is one we did on our homework, so let's walk through this, see how everybody came out. Anybody want to throw out what their answer is for x? 0.8261. Okay. 0.83. So same thing. Okay. Well, let's take a peek. One thing I will say when we're doing these problems, we didn't really force the issue on significant digits. We talked about it a little bit last semester, but we kind of left. We didn't get really tight about it. So what I'll generally tell you is whatever the information is given in the problem, go one decimal place beyond that. So here, this number is the nearest hundredth. So I'd ask that you take your answer to the nearest thousandth. So I'd say 0.826 would be where we'd want to round it. That's part of it. And that's so that whoever's using that information can round it themselves. Because they generally will round it to the number of decimal places in the problem. But if you give them one extra decimal place, then they can round it themselves. Even if you want to round it, a lot of times there's cases where it's nice to know what that next digit was. So you know what your error is, what your loss is in the rounding. Okay, so anyway, we are going to cut this like this. Putting in the radii, we know those are right angles. What do we do next? Create a rectangle from this center over to here. So this is, of course, 0.4. This piece is 0.4 because it's the opposite side of that rectangle. But of course, we know that the whole length here has to be what? 0.6, half of the 1.2, which means this piece here is 0.2. So that's all going to be important to us. Next, I'm going to connect the centers of the two circles. We know that this side here has to be x. What do we know about the blue side up here? 0.85. So we have that triangle there. This is 0.2, 0.85, and x. And yeah, the right angle is here. A lot of people want to try to put the right angle up here. It can't go there. It's got to be here. If this angle's right, that one has to be right as well. So now to find x, it's simply going to be a squared plus b squared equals c squared. Of course, the shortcut is x is going to equal the square root of 0.85 squared minus 0.2 squared. So 0.8261, 0.826. Now, one of the other reasons why you want to go that one digit past what is given in the problem is if you need to use that number for calculating anything else later on, you have that extra digit so you don't get the huge round off errors in that next calculation. So now, to find this area, I'm going to look at this piece up here that I just drew in is the same area, which is the same shape and everything as this piece down here. So if I can find this area, I just double it and I'll have both of those areas. So this area down here, I'm going to break into two pieces. Piece one is this rectangle. How do I find its area? Well, this is length times width. 0.4 times 0.826. It was 0.3304. That's in square inches. This triangle here, which is just this triangle here, by the way, 0.2 times .826 divided by 2 because it is a triangle. It gives us 0.08. No, 0.0826 will go. Inches squared. We're going to add those together and we're going to double that because remember we said there's one up here that's the same shape. So we're going to add that together. 0.413 times 2, 0.8260 square inches. So that is this part right in here that I've got highlighted. So now I need this part of the circle here and this part of the bigger circle up here. I need an angle to do that. So let's find this angle right here in this triangle. I'm going to use the sides that were given because there's no round off error there. So the 0.85, of course, is the hypotenuse. The 0.2 is which leg? The adjacent leg. Hypotenuse and adjacent is what function? Cosine. Cosine theta equals adjacent and hypotenuse. We have the adjacent side is 0.2, the hypotenuse is 0.85, and we are looking for the angle, which means we need to do inverse cosine. So the cosine and inverse cosine cancel out. Theta is equal to the inverse cosine of 0.2 divided by 0.85. Close those parentheses. 76.39 degrees. Now I'd said earlier go to one digit past what's given in the problem. It's pretty standard for angles to round to 2 decimal places. And there aren't any other angles in the problem to really compare to. So we have that angle here, which is this angle right here. If I double that angle, (152.78), I get this whole angle here, which is going to be the same as this one. So that's 152.78 degrees there. This is going to be 360 minus 152.78, which is going to be 207.22 degrees. So I have those angles. To find the areas, let's do this little one here first. I'll call that part 3. It's the area of the circle. Pi times 0.4 squared times that angle. 152.78 degrees over 360. Remember, this here is just the fraction of the circle, the whole circle. So 3.14 times 0.4 squared times 152.78 divided by 360 is 0.2132. For 4, it's pi times radius squared, so pi times 0.6. It's the bigger circle, is radius 0.6, times its angle of 207.22 degrees over 360. Again, that's just the fraction that is of the bigger circle. So pi of 3.14 times 0.6 squared times 207.22 divided by 360. 0.6507 inches squared. I now need to add those 3 numbers. I get 1.6899 square inches. If you had 1.690 square inches, that would be acceptable. Anybody have that? Close. Any questions on how I got to that? Okay. Okay, well then let's look at problem number 2 of your homework. So for that one, number 1, x was 0.826 inches, and the area was 1.690 inches. For number 2, give you a half circle with a radius of 24 inches. This tangent comes off here to this being 8 inches. This is a 1:4 aspect ratio. I'm going to start with this aspect ratio, this corner right here. If I draw in a right angle there, I know this angle here comes from that aspect ratio. I can think of that as being a triangle that looks like this. 4 on the horizontal, 1 on the vertical. Rise of 1, run of 4. This angle right here is just going to be the inverse tangent of 1/4, which is going to be the same as this angle right here. (14.04 degrees), which gives us then that this bigger angle is 104.04 degrees. How did I get that? Just added 90 degrees to it, right? Next, I draw in this radius from the center, that point of tangency. That has to be a 90-degree angle. Yes, of course, all radii of that circle are the same length. So that's still 24 inches. So the question becomes here, how do we divide this up? Well, if I had given you this length here, if I had given you that amount, then we would know this whole length, and I could cut it like this, and it would be easy to do. But I didn't give you that length. So it's not so easy to do. In fact, to solve this problem, I'm going to need to figure out what that length is there. So I'm going to call that x, even though it wasn't part of the problem. It's something I'm going to have to do anyway. So I can't divide it up that way. I have to divide it up into right triangles where I know the angles. So here's a right angle up there, and there's a right angle here. At the moment, making any right triangles with them doesn't work. So I have to look for what other angles do I know. I have to, it doesn't just help to make a right triangle. I have to make a right triangle where either I know 2 out of the 3 sides or I know one of the other angles. So I look at angles that I know to see if I can form right triangles using them. And at this point, I really can't. So I have to see if there's any other angles I can figure out with the information I have. If I look at this figure right here, how many sides does it have? 4, which means it needs to have an angle sum of how much? 360. So I know 3 out of the 4 angles. I have 90, 90, and 104.04. So this one here has to be 75.96 degrees to add up to the 360. Now that I have that angle opens up some options. I can form a right triangle off of that angle by just doing this. I can cut this right down here. There's a right triangle. I can form another right triangle up here now off of this 14-degree angle by coming right into that piece. Now the way I have this divided up, I can find my missing sides and I can find the areas. because this piece is just a rectangle, this is a triangle, this is a triangle. Then over here I'm going to have an arc of a circle, and I know this angle here to be 104.04 degrees because I know the 75, and that's half a circle. Has to have 20. No, I can't, because I'd be cutting that angle in half, and then what? How does it divide it up? This one here or this one? This one? From here to there? Well, then again, I wouldn't have any right angles. I'd take out all my right angles. If I cut it across here, I'm taking two of this right angle and I'm cutting it to pieces. I don't know how it divides up. So I know this angle and I know this side. That's only two parts of the triangle. I have to have three. That's the hard part when you go to cut these up, is you can't divide up a known angle because you don't have any idea how it gets divided up unless you have other information. So let's take a look here at angle 3, or triangle 3. Triangle 3, we know this is 75.96. We know this is 24 inches. And we want to find both other sides of this. So I'm going to call this here A, this B. If I want to find A first, that would be the adjacent side according to the angle I have. B is going to be the opposite side. I'm going to use my given information, which is that radius of 24 inches, which is the hypotenuse of this triangle. So if I'm finding A that's adjacent and hypotenuse, that's cosine. So cosine of 75.96 degrees equals A over 24. Put this over 1. I'm going to cross multiply and divide. So 24 times the cosine of 75.96 divided by 1. I get that A is 5.822. B is the opposite side, so I'm going to use the sine of the 75.96 degrees equals B over my hypotenuse of 24. Put that over 1. I'm going to cross multiply and divide. So 24 times the sine of 75.96 divided by 1. 23.283. So up here I have this piece, 5.822. Up here, this whole thing is 23.283. What I care is that this piece has to be 8 inches. This piece then has to be the 23.283 minus 8, which is 15.283 inches. Now that I have that, let's look at triangle number 2 up here. Triangle number 2, we now know that this side is 15.283 inches. Let me redraw that. Give myself a little more room. This angle over here we had found before to be 14.04 degrees. We want to know, I'm going to call this down here D. We want to know that side is really all we need to know there. So that's going to be the opposite and the adjacent side. That's going to be tangent of the 14.04 degrees equals 15.283 over D. So I have to put this over 1, and we will cross multiply. 1 times 15.283, which is 15.283, divided by the tangent of 14.04. Gives us 61.115 inches. So up here, this dimension is the same as the one here. This is really the one I just found, was this up here. But this one down here is the same, that's 61.115. Now, I said at the beginning, this dimension x is one that we're going to need to find. And in essence, I did just find it. Because if I add these two together, I get, what? 66.937 or something like that. I know from here to here is 24. I just subtract 24 and what's left is x. So I needed the information that told us how big x is. It wasn't necessarily x itself. But now I can come back and find the area of this. I have rectangle 1 there is 61.115 by 8. This is going to be in square inches because both of those are inches. So 488.92 square inches. Triangle 2 up here, right here, is at 61.115 by 15.283. Of course, because it's a triangle, it's divided by 2. So that's 467.010 or 01 square inches. Triangle 3 is this one right here. That's 5.82. 5.822, I should say, times 23.283. That's divided by 2 because it is a triangle. So that one is only 67.78 inches squared. And then we need that sector of a circle. So it's going to be the area of the whole circle, pi times the 24 inches squared. So 3.14 times 24 inches squared. And then times that angle of 104.04 over 360. Giving us 522.70 inches squared. So our total area we find by adding that all up. (1,546.41 square inches is the total area. Anybody get that on the second one? 1,546.41. Anybody have questions on how I got that? Well, let's take a look at this. Similar problem. So I've got a circle with a diameter of 140 millimeters. Down here, I'm told that this is 72 millimeters. This is a 4:1 aspect ratio. Find that height x for me. Well, what I'm going to do is this. I'm going to cut this across here. I'm going to cut it down this way and down this way. So what I have here is a rectangle. This portion of that is 72 millimeters. This angle right here is found by this 1:4 aspect ratio. If I draw it like this would be 1, this would be 4, and this is that angle. So that angle is the inverse tangent of 1/4. The diameter is 140. So that angle is 14.04 degrees again. From the center of our circle, we're going to draw these out. I didn't state it, but these two lines here are tangents. That's the only way this problem is possible, is if we know those are tangents. So that means that these hit at right angles here. What does that tell us? Well, we know that this angle here is 75.96 degrees. How do I know that? Yeah, we've got this triangle here. We got 90, we've got 14.04. Using the 180 degree angle sum, that has to be 75.96. Which means this angle here, since that's a 90 degrees, we subtract 75.96, that's 14.04 degrees. Which of course makes this 14.04 degrees. So then we can find that angle there, using the 180 degree angle sum, is 151.92 degrees. So making that triangle a little bigger, we've got the 1404, the 1404, the 151.92. This is the radius. The diameter is 140, so this is going to be 70 millimeters. And 70 millimeters. We now know all of the dimensions of that triangle. I could use law of cosines to find this dimension if I wanted to. I know that, let me call that C, that C squared would be A squared, which is going to be 70 squared, plus B squared, which would be 70 squared, minus 2 times A, which is 70, times B, which is 70, times the cosine of the angle of 151.92 degrees. I get 135.818 millimeters there. Or, I know the law of cosine, so it doesn't bother me to jump into it like I just did here. I have it memorized, so I don't have to look it up. But for many of you, you'd have to look that up, and that's understandable. I could have cut it down the middle like this. This is 1404 and that's 70. This would be the adjacent side. That would be a cosine. cosine of 14.04 degrees equals, if I call that missing dimension here D, so I would just go from here to here, it would be D equals D over 70. Put that over 1. I don't know where my D over 70 just went. I'll put it back in. So it'd be 70 times cosine of 1404 divided by 1. Gives us 67.90. That's half of it. If we doubled it, we'd still have the 135.818. So we're going to get here either way. So for most of you, dividing it down the middle, since we know this is an isosceles triangle, we can divide it down the middle and we know it splits it in two. It's just as easy to go that route and do it. Why do we want this information? Well, we want this information because we're going to do some dividing up here. I'm going to find the height of this right here, this dimension, off of this triangle on this side over here. According to the 1404, that would be the opposite side. I have the hypotenuse still, so that's going to be a sine of 14.04 degrees. I'll call that, well, I'm just going to leave it as opposite. That opposite side over my hypotenuse is 70. I'm going to cross multiply. So 70 times the sine of 14.04. 16.982. So now looking at this here, I do have this height from here to here, 16.982. I know this height from here to here is just the radius of that circle, that's 70. If I could find that height going down, I would have it. Unfortunately, right now, that's not there for us. So what can we do from here now to find that height going down? Yes, we're going to use one of these lower triangles. Here's our right angle. This is 14.04 degrees. I need this dimension here. If I had that dimension, I could find this dimension. To get that dimension, I'm going to look at this line across there. I know that, yep, there you go. I know that whole line is 135.818. Well, I know that comes right out of the middle. The 72 comes right out of the middle of it. So I'm going to subtract 72 from it. Which gives me 63.818 left over. And that has to be centered because the angles are the same on both sides. So I'm going to divide by 2. Gives me 31.909 here. And 31.909 here. So this side is 31.909 millimeters. Now that we know that, we can find the height. This is the adjacent side. The 31.909 is the opposite side, so we're dealing with a tangent of the 14.04 degrees equals opposite 31.909 over that adjacent side. Put this over 1, we cross, multiply, and divide. 31.909 divided by tangent of 14.04. 127.600 millimeters. So this from here to here is 127.600. We're going to add those three measurements together. which is what, 214.582 millimeters. That's X, equal to Y. The key to these problems, as I said, is finding those right triangles. And remember, we had two strategies for finding right triangles. Strategy number one, vertical and horizontal dimensions. They have to intersect at right angles. Strategy number two, a radius and a tangent of a circle. Those have to intersect at right angles. There are other things that happen that make right angles, but those are the two big ones. Okay, I have another worksheet I'm going to give you. I'm going to pass that out right now for you. There is a quiz tomorrow on problems similar. Actually, you know what? How many of you had the right area on the problems we did today? What I'm going to have you do is I'm going to have you rework the area, I think. Because the areas are on that quiz tomorrow. I'm going to have you rework that tonight. So rather than giving you a new worksheet, I'm going to send you home with that same one tonight and just have you rework the area, see if you can get it to come out the same way I did, and we'll go from there. So no new homework tonight. We'll have you just rework that last one.